Hey, how's it going? Hope you're doing well. I wanted to put an addendum in there for pyrovalence for the last video. It's for a couple of videos, just some corrections. So, I mean, I make errors in this stuff. I am dealing with a ton of data here, trying to present it. My main goal here is to, just show you this stuff so that you can understand, how to use it to be more effective. That's my goal. But I'm human. I make mistakes. So a couple of corrections. On the ETN video, I stated that the pyrovalence was -10. That is true if pyrovalence went to carbon monoxide. So that's what I calculated for. So I don't know if I was probably doing another, RDX calculation or something right before that, and then just went ahead and did carbon to carbon monoxide. So ETN is actually, -2 when you solve it for carbon dioxide. So that's one slip up. The other one, in the last video, I noticed that, there was a confusion between glucose and sucrose. So those are they're both sugars, right? So when I say in the video when I talk about like sucrose being sugar, that's true, and glucose is a sugar also. And their valence states are both +24. But in terms of the example of how I wrote the example out, somehow I messed up and wrote glucose again for sugar. So glucose formula is on there twice. But nevertheless, it's still the same effect. It's just if you went through and if somebody was trying to reproduce those examples, it might get kind of confusing. So just understand that, glucose and sucrose are both 24. They have different chemical formulas. So in the last video, we went over basic pyrovalence just to kind of familiarize you with it. And it's sort of difficult, I'd admit from that, to see the power of pyrovalence. So there's some comments that they were confused on why what the advantages are versus traditional methods of stoichiometrically balancing a redox reaction. And so what we're doing in the video, what I'm doing for you is just reproducing or emulating the traditional process, but it's entirely unnecessary. So we can really get pretty expedient using pyrovalence in producing the same results. That's not the ultimate power of pyrovalence. The real power comes into simple analysis of complex mixtures, making adjustments to mixtures, and I'll cover that whenever we get into the second video. It might be a little bit of time. We'll probably finish ETN before we do that. For the ETN video, we are going to try a couple of different balanced mixtures, adding some fuels to ETN. And so I wanted to just to demonstrate the expediency of pyrovalence and how powerful it is. I mean, the full power of pyrovalence is probably undiscovered. There are certainly functions and parameters that, are probably unknown. I mean, it's certainly, the limits of pyrovalence are certainly beyond my comprehension, so like I can see what people work out or what I see when I'm doing the equations, but there's probably hidden gems in there that aren't even discovered yet. Anyways, it's a link between the two temporal spaces, before the redox reaction and afterwards, and it's really powerful in its function. But just to kind of demonstrate, from the last video, like I said, I'm just going through stepwise to show you how it is correct and effective, and you can check all the work, and it's going to work and function exactly like traditional stoichiometric balancing of an equation. But that's not really the expediency of using a pyrovalence. So let me just demonstrate that, and to do that, we'll just go over an ETN composition. We're using ETN secondary explosives, and we're going to mix it with a fuel. And the fuel that a lot of people are excited about is PETN. PETN is a fuel explosive, whereas ETN is an oxidizer explosive. But they have a lot of similarity in performance, and so they can sort of make up for each other's shortcomings. And we're going to do that by balancing it with pyrovalence here. So what we do first is, hopefully you can see this. So what we do first is, the first thing I do is I'm going to write out, I've got my ETN. I look up the molecular weight for it. It's 302.108. And then I'm going to calculate the pyrovalence of it. I've already done this, so -2. That's our pyrovalence for ETN. And then we're going to have PETN. Okay. keep in mind how quickly this is occurring here. This is way, well, you can be the judge for it. You be the judge of it. I'm just going to work this out and show you how I would do this. This is what you could do in the field. So what I'm doing here is I'm just factoring right here. So I'm going to go 1 and 2. So we're going to do this as quickly or as efficiently as possible. So we've got our factors done right there. So we're going to go 2 ETN, but we're not going to even write anything about ETN. We're just going to put the molecular weight, 302.108. And we're going to go, 1 would be the other one. Petin at 316.137. Okay, now hopefully at this point you can kind of get the idea of how this shakes out here. So we solved that 604.216 for ETN plus 316.137 of Petin. When we work that out, that's what that's going to equal. Go down here to a new line. What that's going to equal is going to be 920.35. That is 100% of the composition. And we need to find the percentage of the ETN, which is 604.216. So that's going to give me 65.65, and that's my percentage of ETN. And then I'm going to minus 100, which is going to give me negative 34.35. Discard the negative. Now we have our, this is Petin. So now we have our ratio. These are our ratios of ETN and Petin. I don't know if there's a more expedient way to come up with a balanced composition for an explosive. That's by far the fastest. You can easily do this. You can memorize. Really, for most explosives, you can memorize the molecular weights if you're using them often enough. But even if you didn't have to do that, all you need access to, if you don't know it, is the chemical formula and the molecular weight, and then everything else you can do, by memorization, and you're going to have an extremely efficient route to, quickly balancing a fuel and an oxidizer right here. So this is just a short example of how powerful pyrovalence is, and when we get into multi-component, PBXs, EBXs, things like that, things get really complicated, and it's almost impossible to do this without being an extremely skilled technician. But with pyrovalence, it makes it something that's completely accessible. If you can do this, you'll be able to do multi-component configurations of advanced energetic designs.